Hello and welcome to yet another video. As you can see, I've done a little bit of disassembly on the air-cooled DMOC645. I've pulled out the tons of screws to hold the back cover on and took out the main processor board. So I got the processor board on a workbench, so if you're motion sick, close your eyes. Okay, you can open them now. So here's the processor board. It's identical to the water-cooled version. So what we're looking for is, we know CC Shell stores data in the EEPROM because it says we're going to update the EEPROM when you make the changes. So somewhere on this board is an EEPROM. We just got to find it. Unfortunately, it's conformal coded, so I don't know if you can tell, but you can't. It's very, very, very difficult to read any of the labels on any chip without shining a flashlight on it. And there's tons of chips that could be the EEPROM. You would expect, maybe it could be one of these little tiny guys, it could be one of these guys, anything that's near the micro would probably be a good candidate for being EEPROM. There are two I2C buses on here, which is typically used to connect to the EEPROM, and you can see right here, it says I2C. So I hooked up the logic probe to that, and they're not used. Both I2C buses are completely not used, and there's never any traffic on them. Which is interesting because they went through all the trouble of having common mode chokes and everything on there, but they're not used. So the next thing I did is we looked around and I know this thing has a real-time clock calendar chip because it shows up on, when you hyperterminal in, it tells you the date and time. And this is the battery that runs it. So if you trace that over, you can tell it goes into this guy, which is the real-time clock calendar chip. Well, it's interesting, you're like, well, real-time clock calendar chip, that's not an EEPROM. Sometimes they actually do have EEPROMs in them. Unfortunately, this one doesn't. It just has 128 bytes of battery backed up SRAM, and they're not going to store critical parameters like the box type, which we're trying to change, the max voltage of 400 volts and the max current at 600 amps, all the IGBT stuff, limits, other hardware limits, your calibration for your for the current sensors, the calibration for your voltage sensors, all that kind of stuff, they're not going to store in something that could get erased if this battery died. So, but one thing we do know by looking that guy up is how does it connect to the micro? And if we look that up, it is a DS3234 extremely accurate SPI bus, real-time calendar and clock with integrated crystal and SRAM. So this tells us some interesting information. One, that it's connected via SPI, which is good to know, and that it runs at 4 megahertz. And with that information, we know the SPI bus has to get from here to here. And we know that EEPROMs are typically stuck on SPI buses if they're not on the I2C bus. And sure enough, if you kind of draw a line, because you want the shortest path possible, right? So it probably snakes in through here somewhere, and boom, right here. U51 is in fact the EEPROM. It's actually not an EEPROM, it is a flash chip. So the number on it is, this one's actually, it's a 45P E20. It's actually the ST version, but of course, ST Microelectronics disavows all knowledge of ever making that chip, but this other company, it used to be Micron, that's what the M stands for, flash memory chip. It's a SPI, 75 megahertz, 3.3 volts, and has 2 megabit, which is actually 256 bytes of memory. So they're definitely storing it in there. If you look, I've added some little wires. If it focuses, focus. One of these days I'll get a real video camera instead of just using my cell phone. There you go. But you can see I've actually added a bunch of wires to it. This is the same footprint that it's on. So they have provisions to add a second flash memory chip if they needed it. I guess if they had a whole lot of parameters to store in there, you could use two. But essentially there's two, it's got these little pads on the sides of the actual footprint, and that's what I soldered to. So I didn't actually scrape off the conformal coating or anything on the chip itself, I just scraped off the coating and soldered some resistor leads to the little pads. And the pinout is your standard flash memory pinout, which is, it's different than like the EEPROM pinout. But we scroll down here. Whoa, too far. Actually, we want both these pages because it tells you what they are. So pin 1 is D, which is the serial data input. C is the serial clock. Pin 3 is the reset. S is the chip select. W is the write protect. And then VCC is the 3.3 volts. VSS is ground. And the Q is our serial data output. So I essentially just soldered wires up to all of those, and we're going to go ahead and hook up the logic probe to it, and we're going to go into CC shell, and we're going to change 1 bit. Just change 1 bit, and that'll allow us to see what the checksum does. We'll record before and after and see what that looks like. So that'll be the next video. Thanks for watching.